So next problem on Fourier transform. If Fourier transform of if Fourier transform of e raised to minus t u of t is 1 by 1 plus j, then find the Fourier transform of 1 by 1 plus t using duality property. So now the solution for this is, what is given here? Here given is e raised to minus t u of t. This Fourier transform, this is 1 by 1 plus j ohm. Okay, so this is given. Now here we have to use the duality. So using duality, t is replaced by j omega and j omega is replaced by t. So we write here, using duality, t is replaced by j ohm, not omega, j ohm, and it is replaced by t. So this is duality. Similarly, LHS and RHS are interchanged. So therefore 1 by 1 plus t is Fourier transform, this is e raised to minus j u of j. This is the Fourier transform of given function. Next problem is, find the Fourier transform of f of t, where f of t is given e raised to minus at cos of bt. So what is given? First we write the given. So given is f of t is equal to e raised to minus at cos of bt. So it is equal to e raised to minus at e raised to jbt plus e raised to minus jbt divided by 2. So f of t is equal to half of e raised to t minus a plus jb into 1 plus half into e raised to minus t a plus jb into 1. So now we have what we have Fourier transform of delta t is 1. So using duality property, again using duality property, we can write or delta of f. So according to frequency shifting property, according to frequency shifting property, we can write e raised to j omega 0 t x of t, it is x of j into omega minus omega 0. So we can write 1 by 2 e raised to t minus a plus g b, this Fourier transform half x of j omega plus a minus j b, and half of e raised to minus t a plus j b, it is half of x of j omega plus a plus j b. So we can write x of omega is equal to half of x of j, we just combine it, so half of x of j omega plus a plus j b. Now the next problem, for the same function shown in figure, obtain Fourier transform and plot its spectrum. So this diagram is given, it is t 0 1 by t 2 by t and it is 3 by t. This is a is amplitude. Okay, so we write here. Now what is given? The given signal is a sinc function, so it can be expressed as x of t is equal to a c t capital T. Now what is here? Here a is amplitude at t is equal to 0. So we have standard Fourier transform pair. So this equation for this is, it is t by capital T Fourier transform, this is a t sinc of f t. Now here we have to use the duality property. that is we have to interchange it. So using duality property, interchange T and F and interchange LHS and RHS, and also LHS and RHS. Okay, we have to interchange it. So AT sinc of T capital T, Fourier transform, this is A F by T. Now divide both sides by capital T. So we can write this equation as A sinc of T capital T, A by T rectangle of F by capital T. Now we have to draw the spectrum. So spectrum of rectangular signal. F, it is 0, it is T by 2, it is minus T by 2, it is X of F. So it is A by T. So this is the spectrum diagram for the rectangular signal. Now the next problems are based on Fourier transform of standard signals. So first problem in that, Fourier transform standard signal. Standard signal means unit impulse signal, unit step signal, these are the standard signal. So we have to find out the Fourier transform of these standard signals. So first problem is that obtain DTFT of unit impulse delta of n. So now the discrete time sequence is given by xn is equal to delta n. Okay. So we write here discrete time sequence is xn is equal to delta n. This is equation 1. Now according to definition of DTFT, DTFT, we have DTFT of x of n is x of omega. So we can write summation goes from n equal to minus infinity to infinity x of n e raised to minus j omega n. So we can write x of, it is summation n goes from minus infinity to infinity delta n e to x e raised to into e raised to minus j omega, and this is equation number 2. But we know that delta n exists only at n is equal to 0. So delta n is equal to 1 for n is equal to 0, and this value is 0 for all other values. Okay, so equation 2 becomes x of omega is equal to summation at n is equal to 0 1 into e raised to minus j omega n 1 into e raised to n equal to 1. Sorry, e raised to 0 is 1. Now we will draw the diagram for this. So it is n is equal to 0, and here it is 1. It is delta n. So delta n Fourier transform dtft is 1. So this is standard Fourier transform pair. In this way we can find the dtft of unit impulse. Now the next problem, obtain dtft of unit step u of n. So we have to find the dtft of unit step. Now here xn is equal to u of n. Now according to the definition of dtft, x of omega is equal to summation n is equal to minus infinity to infinity xn e raised to minus j omega n. Okay, now dtft of un is x omega, which is equal to summation n goes from minus infinity to infinity u of n e raised to minus j omega n. This is equation number 1. But we know that un exists only for the positive values. Okay, therefore un is equal to 1 for n greater than equal to 0, and this value is 0 for n less than 0. So we can write the limits of summation from n is equal to 0 to infinity. So equation becomes n is equal to 0 to infinity 1 into e raised to minus j omega n. So this is the equation. Now we draw the diagram for this units. So diagram for this is 1, this is n is equal to 0, 1, 2 and 3. So it is dot dot up to infinity, it is un. This is unit steps. Now we can write x omega is equal to summation n goes from 0 to infinity e raised to minus j omega. This is equation number 2. Now we have a geometric series formula. What we have? Geometric series formula. So this formula is summation n is equal to 0 to infinity a raised to n, a raised to 0 plus a plus square plus a cube plus dot dot dot. So we have this formula and it is equal to 1 by 1 minus a if it is less than 1. Now consider next step is let a is equal to e raised to minus j omega. So equation 2 can be, it is equal to 1 by 1 minus e raised to minus j omega. This is equation number 3. Now if we put omega is equal to 0 in equation 3, then x omega is equal to infinity. If we put omega is equal to 0 in equation 3, then x of omega is equal to 1 by 0 is infinity. That is omega is equal to 0. The dtft obtained by equation 3 is not valid. We write here dtft obtained by equation 3 is not valid. So we should obtain x omega. So obtain omega for different values of omega other than 0. Okay, so we rearrange equation 3 and we get this equation becomes, it is equal to 1 by e raised to minus j omega by 2 just rearrange this equation and this is equation number 4. Now value of this e raised to minus j omega, value of e raised to minus j omega by 2 into e raised to j omega by 2 is e raised to 0 is equal to 1. Okay, and value of this e raised to minus j omega by 2 is, so we take the common e raised to minus j omega by 2 common from the denominator, it is plus. Okay, so equation becomes, it is equal to, we just take common e raised to minus j omega by 2 this is equation number 5. Now according to Euler's identity, we can write e raised to j omega by 2 minus e raised to j omega by 2 divided by 2 is equal to j sin omega by 2. So equation 5 becomes, we replace it, so it is equal to 1 by e raised to minus j omega by 2 into 2j sine, we use this Euler's identity. So the equation becomes x omega is equal to e raised to j omega by 2 divided by 2j sine thus u of n dtft of this is e raised to j omega by 2 divided by 2j sine omega by 2. So this is the answer. Now the next problem is obtain. Next problem, to find the DTFT of standard Fourier transform. Standard signal. Obtain DTFT of rectangular pulse xn is equal to a and it is equal to 0 for it is less than n l minus 1 and this value is for other value. So solution for this is, we have to draw the diagram first. So it is n, x of n, it is a, so this is 0, 1, 2 up to l minus dot 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 up to l minus 1. So this is n is equal to 0. Now here a, what is a? A indicates the area of rectangular pulse. A is area of rectangular pulse and L, what is L? L is length. L is length of pulse, rectangular pulse. L is length of the rectangular pulse. So according to the definition of DTFT, we write here, according to definition of DTFT, we can write x of omega is equal to summation n equal to minus infinity to infinity xn e raised to minus j omega n. This is equation number 1. Now what is xn here? Here xn is the present only in the range n equal to 0, but we write here x of n present only in the range n equal to 0 to n equal to l minus 1. So equation becomes, it is equal to summation goes from 0 to l minus 1 a e raised to minus j omega n. This is equation number 2. Now next is here area A is constant, okay, area is constant and it is independent of limits of summation. So x of omega is equal to a, n is equal to 0 to l minus 1 e raised to minus j omega raised to n. This is equation 3. Now we use the standard summation formula. Standard summation formula, what is that? It is n k is equal to n1 to n2 a raised to k is a n1 minus a n2 plus 1 divided by 1 minus a. So here a is equal to e raised to minus j omega, n1 is equal to 0 and n2 is equal to L minus 1. Now equation 3 becomes x of omega is equal to a into e raised to minus j omega 0, e raised to minus j omega L minus 1 plus 1 divided by 1 minus e raised to minus j omega. So we can write this equation is equal to a into 1 minus j omega L by 1. So this is equation number 4. Now rearrange the terms to use the Euler's identity. Okay, so we have to rearrange the term to use the Euler's identity. So we write here so for numerator we put 1 is equal to, we write here for numerator put 1 is equal to e raised to j omega L by 2 plus into e raised to minus j omega L by 2, and e raised to minus j omega L is equal to and for denominator we put 1 is equal to e raised to j omega by 2 into e raised to minus j omega by 2, and e raised to minus j omega is equal to so we substitute these numerator and denominator values. It is a into we just substitute these values here. So we substitute this numerator and denominator values and we solve it. So we get x omega is equal to a into e raised to minus j omega L by 2, e raised to minus j omega by 2. This is equation number 5. So next is according to Euler's identity. According to this Euler's identity, we can write sin x is equal to e raised to jx minus e raised to minus jx divided by 2. Therefore, e raised to jx, e raised to minus jx is equal to 2 sin x. So we replace this. So above equation x of omega becomes it is equal to a into e raised to minus j omega L by 2 into e raised to minus j omega by 2 2 sin omega L by 2 divided by 2 sine omega by 2. So it is equal to a e raised to minus j omega L minus 1 by 2 sine we just simplify these equations here. So this is the dtft of the given function, or we can write this equation as therefore dtft of this is a e raised to minus j omega L minus 1 by 2 sine L by 2 divided by so we can also write this function like this. Next problem on this, determine discrete time signal, determine discrete time signal xn whose Fourier transform is x of e raised to j omega is equal to 1 and it is 0. This is 1 for the values and this is 0 for the values in between pi. So now the given signal we have to plot here. It is omega, it is 0, it is omega c, it is pi, it is minus omega c and minus pi. So we can plot this signal. We plot here the signal. Now we have to obtain the xn, which means we have to take the inverse Fourier transform of the given function. Okay, therefore x of n is equal to 1 by 2 pi integration minus pi to pi x of e raised to j omega into e raised to j omega n d omega. This is equation number 1. But we have x of e raised to j omega is equal to 1 for the range minus omega c to omega c. So we can write this equation x of n is equal to 1 by 2 pi minus omega c to plus omega c 1 into e raised to j omega n into d omega. So we solve this. So we can write x of n is equal to 1 by 2 pi is constant, e raised to j omega n divided by j n minus omega c to omega c. Now we substitute these values here and we can write 1 by 2 pi to e raised to j omega c n minus e raised to minus j omega c n. Now according to Euler's identity, what we have sine x is equal to e raised to jx minus e raised to minus jx divided by 2. So this equation becomes xn is equal to 1 by 2 pi n. We apply this Euler's identity here and this equation becomes into 2 sine omega c n. It is sine of omega c n divided by pi n. So this is the discrete time signal. So in this problem we have taken the inverse of the Fourier transform. So for unit impulse the discrete time is delta n and dtft of this is 1. For unit step it is un. For dtft it is e raised to j omega by 2 divided by 2j sine of omega by 2.